Here's an autonomous vehicle done by Embry-Riddle on a contract with FDOT, and as you can see, it's got multiple sensors. It's got a camera up front. It's got a LiDAR system that's scanning 360, and then inside the computers to handle it all. It takes a lot of firepower to run this. The whole hatch area is filled with computer. Then you've got power supply, rack, and a laptop.
So what you're seeing here is the 64 beam laser rangefinder that's mounted on the roof. And you can see that the color is different based on where the laser's coming from. So that's actually the light intensity. So you can see it's blue from the light intensity of the pavement. The reflection, you don't get much reflection off of the pavement, but you can see things like reflective cones, reflective signs have high intensity. So here is that white sign right there for the cruise terminal. And that has a much higher intensity.
So we're putting this vehicle with all these sensors in some challenging situations, recording all the returns from everything, and then doing some data analysis to go back through and look at what kind of results we're getting.
Yeah, that's a good question to answer. As we go with that can be intercepted. So we go with optical.
This is an ex-military Humvee, and it's using a camera-only system. Cameras mounted on the roof to go off-road, and that's what the ride was all about.
We're based in San Antonio, Texas. We do a lot of work with FDOT related to advanced traffic management systems. We have some groups, fairly large groups, that do connected vehicle and autonomous vehicle research. So we're here, FDOT invited us here to showcase some of that. So what we'll be demoing today is some of our off-road capabilities. We've done quite a bit of work both on-road and off-road. So driving on city streets, interacting with traffic, pedestrians, things like that. We've also gotten a lot of interest and a lot of work from different groups in the military. So we've done programs with the Navy, the Marines, as well as the Army to develop off-road autonomous vehicle capabilities. So the Navy was really interested, and that's really what this system is very similar to a program we did with the Navy. They were interested in an autonomous resupply capability. Rather than have those soldiers kind of hike back 10 or 20 kilometers or have soldiers drive trucks loaded down with equipment to meet up with them, they were interested in having an ability to fly in a vehicle like this, maybe in a B-22 Osprey or something like that, loaded down with food and water and ammunition that the soldiers needed, drop it off into a largely unknown but safe area, and then have it autonomously navigate to meet up with those soldiers so they can get their equipment. So at this point, I put the system into an autonomous mode, so the system has control. I came out yesterday and just kind of surveyed a set of points. It's going to take us down to the end of the straightaway, pull a 180, and come back and basically stop in the same spot.
So does it see things like the telephone pole and the signposts over there and can avoid them?
Yep. So we go back and look here, you can see, in this representation, this is really showing the range data. So we're seeing kind of the fence line off to the side, telephone pole off to the left, and we'll see that kind of update as we go. But the terrain is relatively flat right in front of us. So I'm gone hands off at this point. And so again, I kind of provided a rough set of points for the system to hit, but it's really using that sensor data coming from the camera system to kind of feel its way around, figure out where it's safe to drive and where it's not safe to drive.
It automatically governs the speed and everything, doesn't it?
So I'm not pushing on the gas pedal or the brake pedal. So as part of the points that I surveyed, I kind of set a maximum speed limit of about 10 or 12 miles an hour. But it's also looking at other things like how curved the route is, how tight of a turn it's going through to adjust the speed limit. If it recognizes a person or another vehicle kind of getting close to where it's driving, it may slow down. Or if they hop right in front of it, it may stop until they get out of the way.
Here's Embry-Riddle's autonomous lawnmower, which will be used at airports. As you can see, the student on board isn't moving any controls. The mower is doing its own thing. It may look like Disney World, but it's not.
It has 4 sensors.
This is an
on each
automated
quarters, and they use LiDAR technology.
shuttle taking people on rides at the port.
Yes. So this is a touchscreen right here. We already have the points, point A and point B mapped out for where it'll go. So I'll go ahead and select the arrival location, which is just down there. I'll hit the start. These doors will close. There they go. And we will be on our way. So this is just an emergency stop button. It's not actually controlling it. You can see it's not motion sensitive. I'm not doing anything. This is just in case for some reason the technology just goes offline. Then there's a way to stop it to make sure that it doesn't like go through the fence or anything.
So the bottom line at this conference is that autonomous vehicles are coming. In fact, they're here right now. For Jacksonville.com, I'm Dan Scanlon.